Welcome, everybody, to the Dev Days conference. You are in the hall for languages and frameworks. And the first session that we have today is called Why Care About Functional Programming? Now, see, I use C Sharp and .NET in my programming life. And many years back, I was in a company as in a meetup, and that's the first time I heard about functional programming. And these guys were using F sharp to take care of their continuous integration and continuous development. And I'm like, this sounds highly mathematical, very nerdy. And how do they even do this? And today, Bogdan is going to tell us why should we care about functional programming. And I'm very excited because he does very interesting such stuff with vehicle routing using Scala and Rust. And guess what? Not just programming, he also does ski-fi stories in his own blog. So I'm looking forward to Bogdan's session on why care about functional programming. So here we go, Bogdan. The stage is yours.
Yeah. Hello, folks. I want to tell you why should you care about functional programming. This talk is intended to be an introduction to functional programming to people who already saw a couple of introductions and they have a vague idea, but they're still not impressed. Why should they use it? But yeah, if it's your first introduction, then don't worry. I'll bring everyone to the same page. And first, let's see, who am I? Yeah, I'm a software engineer at Moya. We do ride pooling services for cities, including autonomous driving. And to give you some scope of my experience, my second programming blog a week ago turned around 10 years old. Another disclaimer, there will be a lot of code examples in this talk, and they're all in Scala language. It's mostly because I like it, but also it can do both functional programming and imperative programming. That's how I will call non-functional programming today. And it doesn't enforce the single way of doing it. So it works as a gateway drug for Java developers into functional programming. But also, you don't have to know Scala to read these examples because I will use very limited syntax, so I don't have to explain a lot of off-topic stuff. And let's all get to the same page. This is the typical introduction to functional programming. First, look at this. This is a function. It's wonderful. It's what we call a pure function. It means it returns a value and does nothing else. It doesn't access or modify the global scope. It doesn't throw exceptions, make network calls, or nothing else. Just returns the value. But what if I tell you it can be even better, like this? So what changed now? Before it was a function definition. Now it's a value definition of a value with type function. And it's the same function. And it might seem that there is no real big change, but the contextual change is huge. Because the previous function, it was like a button glued to the wall. You can push it, or you can go away. And that's all you could do with it. But the value, which is a type of function, it's like a button on a remote. You can push it, you can take it around with you, you can wrap it in a box, you can put it in a pocket, or you can give it to someone else. From programming perspective, it means you can pass it around and you can pass it to another function, or you can return it from a function. The functions that accept or return functions as arguments, they are called the higher order functions. And let's look at the most popular one. It's a map. That is a generic function that receives a list of values of any type, and a function that takes one value of that type and converts it to another type. And the whole map function returns a list of that another type. As implementation, it just calls in built-in map function on a list because I was lazy to implement it. But yeah, together it works wonderful. We can have a list of numbers and we can have the same square function, and now we have a list of squares. But yeah, map is not the only higher order function you might see. There's also a flat map when we turn every value into a list of values, and we receive a list of lists, but then we flatten them into a single list. So now we have a list of both numbers and their squares. And yeah, it quite nice. It shows you exactly what you need to achieve. So if we make the same code in imperative style, it will be something like this. We need to create a mutable list buffer, and we can need to iterate over every number in our original list, apply our function, and then append everything to our result buffer. And it also works, but it's much more tedious. It's like in the old joke when a guy comes to a doctor and says, doctor, for me it hurts when I bend my one knee, and then I bend, then I straighten up my knee, and I bend another leg. I put the hands down and I straighten up another leg, and then I stand up. And doctor says, well, that sounds quite a weird sentence sequence of actions. Just don't do it. And guy says, but how else can I put my pants on? And yeah, that's often the difference between declarative and imperative code. With imperative, you need to list every action you need to do. And after this, you don't see that big idea, why would you do this? But yeah, functional programming has more. For example, you can compose functions. And compose function is a generic of two types that takes two functions and creates a new function by taking a result of the first function and passing it as an input to another function. And it's quite a paradoxical thing because it changes the world a lot. And still, it's a function I never used in production because it's much easier to just call one function after another. If you look at it, yeah, we can create a function better is42 by composing functions is42 and how do you do, fellow kids? And we get a new function that is from int to string. And that's quite interesting. And the important thing about it because is that compose function knows nothing about functions you are trying to compose, except the fact that they have a single argument and single result value, and result of one function matches the input of another. But still, compose might be implemented somewhere inside the language, and you can use it to compose your application functions. And if you think calling one function after another, it's a code pattern. You need to remember how to do this. You need to be able to write this pattern every day, multiple times. And maybe you are even asked in a tech programming interview, how can you call one function after another? Yeah, that sounds quite absurd when you are talking about something like calling one function after another. But you could see today that another code patterns are also can be changed into code for this thing, and you don't need to remember them because there is a function that remembers it for you. Also, recursion is good now. Just remember it. And that's how you can do functional programming in two steps. First, you need to write some functions, and then you compose them into the program. That's all. Usually, that's how typical introduction to functional programming ends. And after this, you think, well, so what? It might seem cool, it might be even impressive, but then you get back to your day-to-day work. You need to fix some bugs, you need to write new features, and it doesn't look like you feel that you need to compose some pure functions for doing this. So why would you go into functional programming? It's mostly because programming is hard, and we should use every opportunity to make it easier. And for example, let's look at this at this code. We have a class person with two types, with two properties, name and birth date. Case class is just a special type of classes that are defined for storing data. And it has a proper method get age that returns an int and has some implementation. It's not interesting right now. And then we have a code like where we create a person with name Jojo that was born on 1st January 2000. So it's easy to get the age. And we try to get the age and print it. And then, what do you think would be the output of this code? You might think Jojo is 24 years old, but when we call it, we thought it would be Jojo, but for some reason it's Dio. Let's see why it happened. For this, we need to look into the getAge function, and it looks like this. It changes the property of the person when we try to get its age. And again, this two-line example, that sounds very absurd. No one would do this. So let's make it much more realistic, like this. Yeah, now it's quite realistic code. Then, okay, it's a problem. We can resolve it by making our properties immutable. We do it like this. In Scala, it just means remove the var prefix word from before the property definition. So now it should be fine, right? Let's see. Yeah, it's not right. Now we need to look into getAge function again to see what happens. And we see the comment with the famous last words, something you often see during debug. And function definition never tells you whether it throws exceptions or not. There are some conventions saying you need to write it in a comment, but if it's something like 5 functions deep, you cannot rely on comments of every function that is above it, that it will pass the exception notification properly. So yeah, let's try to get rid of this exception. Well, with another comment that I promised it doesn't exception. It should be fine now, right? It should return what we need. And yeah, it returns what we need, but also it drops the database. And yeah, if you look into implementation, yeah, that's what it does. Exactly. We can fix it again by just enforcing getAge to do what we need. And that's usually the problem with imperative programming. You don't know what to expect from a function unless you know how it's implemented. And it means that you need to keep its implementation in mind while you are calling it, which is quite easy when you have a one-liner function. But let's imagine you are updating the main function of your application right now. It means that you need to keep the whole application in your hand. And if someone is able to do this, then the whole team depends on this old developer who know the whole application and know what to expect from the simple call. And yeah, but now it's fine. It should be fine, right? So we can even make a test that validates our code and calls it and validates that it produces the string Jojo is 24 years old, and it will work fine for about 7 months. And then it will suddenly fail. And it's weird that your tests might start failing just depending on when you run it. And yeah, it's mostly because this function depends not only on the birth date of Jojo, but also on the current date. And to make it proper, we should also import current date as an argument to this function. So it's reliable now. We can know what to expect from this function, and it's good testable. But well, it's also pure now. We achieved the pure property of the function just by making it more reliable. And also we achieved one property that matters a lot to functional programmers. It's referential transparency. It means that you can replace a function call with return value of that call, and no one will notice. And we care about it so much because With referential transparency, it doesn't matter when the function is called, where it's called, or if it's called at all. And that kind of explains why functional programming became more popular with asynchronous, parallel, or distributed computing, because pure functions are much easier to make them asynchronous. But also they're predictable. You don't need to know how function is implemented to know what to expect from it. You just need to know this one line function declaration with input types and output types. So functional programming is knowing what to expect from a function and thinking only about the code in front of you, just like life. And yeah, we showed that avoiding side effects makes programming easier, but on the other hand, we want side effects. The only useful things our programs do are side effects, and getting rid of them sounds like counterproductive. So let's see how we can do side effects without making side effects. And for this, we have a simple code with side effects that greets. It takes a name as a string and it creates a string hello name and prints it to output. And let's see how we can do it. Well, first thing, we can just split logic and side effects. Now our greet just creates a greeting string and we print it later, and it doesn't actually solve the problem. It makes code more testable, it makes code nicer, but our problem is still there because someone needs to know that this string needs to be printed. And we just push the problem one layer higher. So we can do something else. For example, we can make the function that says print this command. So knowledge that this string needs to be printed is still in the function, and we can implement it later. For this, we can create a value that says print this command with string, and it should be fine. And what if I tell you it's a real approach, probably used by functional programming, because if you sprinkle some monads on top for composability, it's a free monad approach. I never saw it in production, but books say it was popular some time ago. We can do easier things. For example, we can do better dependency injection, where we make a printer type, something that accepts a string and prints it. And we can expect this thing as another argument to our greet function. Yeah, it looks like dependency injection, but the biggest trick is the type of our greet function. It doesn't define a return type. It just returns whatever our printer returns. And it means, like, if you think, is our greet function pure now? We cannot say it completely depends on the printer function. So our greet function can work both with pure functions and pure functions and doesn't enforce any type. And yeah, it's also popular. Sprinkle some monads on top for composability and it turns into tagless final approach. And it's the top notch, the best, fanciest thing you can do in functional programming right now. But we can also make it easier. Let's make it easier. Another way is we return a lambda function. So our greet returns a function that, if you call it, brings our greeting. And this looks like a dirty trick because we still have this println. But on the other hand, our greet just returns a function. It doesn't do anything else. So greet function is pure. And that's it. But yeah, it's a real method used by functional programmers. Sprinkle some monads on top for composability, and you get the I-monad approach. And that's the main workhorse in functional programming that does all the heavy lifting of side effects in our code. And I want to tell you a bit more about IO, but first I use the word monads multiple times now, and you might be scared. So let's talk about them. And for this, let's compose another program that prints a question, what is your name, reads a line from input, and then prints the greeting. And for this, we use our IO type, which is now not just a function, but a case class that wraps this function. And we have a couple of functions that actually return this IO. One of them is read name that returns a string, and another one is print that returns a unit, which is an interesting type. If you think, for example, the type byte has 256 possible values. The type Boolean has two possible values, true or false. The type unit has only one possible value, unit. And it might seem useless, but it gives it nice properties. For example, you can create a value of type unit at any moment because it's only one type. You know what you won't know what to create. And also you can drop this value without losing any information because it's useless type. And we use it as a placeholder type for things where we need to pass some value, but we don't care about it. For example, our print function doesn't return anything, but ion needs to return something as a result of a side effect, so we can return unit. And we can try to compose these two functions into a program that we need. For example, we print a question, read name, and then try to write a greeting. And yeah, you can see the problems right now already. First, the first two function calls will be just dropped because no one executes them. Only the last print will be executed. But also we need to take the result of read name and pass it as a part of greeting into our third command. And we don't know how to do this. We can return a list of IOs, but still it doesn't fix our problem with passing name from one thing to another. So we need to somehow compose these three IOs in like one big program IO that does everything we need and then returns nothing. So we need a way to compose an IO of some type and a function that takes this result value of the first IO and creates it into another IO. And then we need to get as a result IO that makes both side effects and returns the result value of the second one. And let's do it. Let's call it a flat map, and it creates a new IO that executes the first side effect, then processes the result value and executes the second side effect. Now we can compose our program like this. So we take result of the first command, flap map it into a second command, and flap map it into a third command. And we have access to the name value in the middle, so we can actually turn it into a grid, into a greeting. And with this, we almost invented a monad. So we can get to the definition. Monad is a generic type you can change using flatmap. Just don't tell it to FP purists because it's not a right definition, it's just a useful one. The right definition says that there needs to be a bit more properties to a monad and they need to follow some more laws. But these laws, they just make sure that you can flat map stuff without it exploding so it can reliably be done. And this explains why it's so hard to explain what is a monad. It's a way to chain things that are implemented by other types, and what it does directly depends on what these other types do. So a good way to understand what is a monad is to actually use it some commonly used monads and see what they do. For example, one nice monad is a arrays, something like list. So every array type means there might be many values of A, and when you turn one way each value of your original list into another array, and then you flatten it, you get a bigger list of all the results. And yeah, that's how you can chain lists. Let's look at other monads. For example, option, also known as maybe of something. And I think it does, it says I can have a value of A or I can have no value. It's a functional replacement for nullable values, and you can use it to chain operations that might return no value. For example, if you have 3 operations and each one might return no value, instead of every time checking whether it returns something and failing eagerly or not, you can combine them in a monad, and monads do this eager checking, eager failing and checking for you. So in the result, you have one option of result type. Next thing is result, also known as either. Either is a more generic definition. Result is more use case specific, and it says I can have either a result value of A or an error of E, and it's a replacement for exceptions. You can use it to chain operations that might fail, and then it will return the first failure and not run any other operations that should go after it. Or also, there's a monad IO that says there's an operation that does side effects and returns A. And yeah, you can use it to chain side effects. As you can see, there are quite different things we can chain using monads, and these are only the most popular ones, and there might be many more. For example, there might be monads for JSON encoding and decoding and stuff like this. So one more thing about functional programming is it's using the same pattern for many use cases, and it's nice. And the functional programming languages also introduce some syntax sugar. It's like do notations in Haskell or for comprehension in Scala. So you don't have to write a dot flat map all the time. So we have something like a left pointing arrow, and it's the same code. It does the same thing. So writing monads is also easy if your language supports it. But again, so what? I just told you quite confusing things. Like functional programmers hate imperative programming, but they want to implement something that looks like imperative programming using monads, like with all this mind juggling. And that's quite weird. Like we're going circles. It's not the first time when someone in the tech industry said that something is bad, so we reinvent an alternative. And alternative is the same thing, but reinvented by them and branded differently. But no, I'm telling you, we're not going circles. It's more like the hero's journey in the monomyth when we go into the special world. See the abyss, which probably is monads, but then we return to our original point with special knowledge and superpowers. And superpower of iOS is operations have values now. And it means patterns are code. You can combine operations into bigger operations just as you combine values into structures. And it turns design or programming patterns into function calls, and it helps with stuff like error handling, async, and retriable operations. So let's look how IO code might look. And here I will be using the syntax of Zio library for Scala, and it's not the only library for Scala, maybe not even the best IO library for Scala. And yeah, in different languages, they look different. So you don't need to remember the specific syntax, just see what is possible. For example, we can write asynchronous code, which looks like this. And it looks exactly like synchronous IO operation, because the difference between synchronous and asynchronous, it can be stored within the monad implementation. We, as a programmers, don't need to care about this. And for more synchronous code, for example, we can wait for 2 operations, then return a combined result. And here we do it just by zipping 2 IOs, and we get an IO of 2 values. You can race between two or more operations using the race function or race all function. Yeah, it's nice. I also write some Rust, and we use Tokyo library for this. And there you can also do a race operation, but you need it for this. You need to call a macro that does code generation for you. I also know that in Go, it's a select statement part of the language that does it for you. In Scala, it's just a function call, means we did not need require the support from the language designers to do it. And let's look further. Timeouts. Yeah, just do operation and call a timeout. Again, in Go, you achieve this by doing the race between operation and the timer, which might sound poetic, but I think calling the timeout method declares better what your intention is. We can also work with resources. For example, when we open a file, we should close it after operation, disregarding whether it succeeded or failed. And we can do this by calling acquire release with three functions, one that opens, another one that closes, and third one does operation with the file. And then it will take care of closing the resource for you. You just declared everything you need. And if you need to synchronously make a stack of resources that depend on one another, and just that later have an operation that depends on all of those resources, as you can expect, there's a monad for this. Let's go further. Error handling. We can make an operation and catch all errors and do something for them and return a fallback value. And yeah, that sounds like try except, but the thing is, it's a function implemented by language designers. It doesn't require any support from the language. And it means that there are around 10 or even more error handling functions tailored for different use cases, something you will never have in the language unless it wants to be bloated. And then we can, for example, fall back to other operation, like do operation A. If it fails, do operation B. If it fails, okay, we have a failed operation. We can do some retries just by calling retry, and we can have exponential delays. For example, let's try to do operation A, and if it fails, retry up to 10 times with exponentially growing delay, something we often do with network calls. I tried to implement it using imperative programming. So we need to catch an error. For this, we probably need try catch. And then what do we do when we get an exception? We need to call operation A again somehow. Should we do it recursively? But then we need to also pass some state, for example, number of the retry. And I don't want to bloat our function A definition with this internal state. Or we can do some loops, but again, it means adding a loop where it shouldn't be. So what should I do? Well, my best idea was like this, and it's also horrible, yeah. And it works just because the operation A is a single line function call. If it was something like 5 lines of logic, it would be unbearable. So I did what I could do and asked ChatGPT for this. It produced like 50 lines of horrible code that it does the recursion, then it also forgets immediately the operation result. It increases timeout before waiting for it. But okay, after heavy editing, this should work. And that's how you do it in functional way. You just say that you need retry and you define a schedule for this. Yes, you need to know how to define a schedule, and this is library specific. And probably it has the same ugly logic with loops, recursive calls inside, but it's implemented and tested by someone else. For me, I see a declarative code that exactly tells what I need to achieve. So another benefit of functional programming is it turns code patterns into function calls. And you don't need to remember how to implement them because functions you call remember all for this. And also it means in functional programming, you can use all the bells and whistles of our libraries instead of implementing them. Now, category theory. We're 35 minutes into the talk, and I did not tell anything about category theory yet. And I won't. Don't look into it. When I wanted to get into functional programming, I thought, okay, I need to learn about functional programming. It means I need to learn about category theory. It was a mistake. I was confused by two things at the same time, and category theory didn't provide any benefit for my usual day-to-day work. So it's very useful, especially when you are defining a language or you're making some kind of library. But if you're just getting into it, you can just learn functional programming. Everything useful from category theory was already adopted there, and it's much easier to understand when it's written by programmers for programmers. And get into category theory only when you feel that you are ready. For example, I'm not ready yet. And we're getting close to the end of the talk, and let's look at some conclusions. First, functional programming is not for showing off, really. Don't even try, no one gets impressed. They just joke about category of the functionals and go on. But on the other hand, functional programming is not hard. I hope there was nothing inherently complicated in whatever I showed you today. It's just, well, it might be scary to start because it uses a different vocabulary, but it's all simple things and mostly dirty tricks that make your life easier. And then next thing is functional programming makes code easy to work with because there are less things you need to keep in your head. You need to remember only function definitions of the functions you called and not implementations of these functions and implementations of every function that they call. And as we also could see, applying common sense makes code closer to functional programming. If you want to make your code more testable or more predictable, you make it more functional-like also. And as a result, referential transparency makes things predictable. And with functional programming, the design patterns become functions implemented and tested by someone else. So you don't need to know how to implement it. It's wonderful. And good news, you don't have to rewrite everything in Haskell right now. You can start using ideas from functional programming in your code step by step, and in each step, it will be useful for you, even if you don't go the full length. And first thing is you can prefer immutable values. Everyone knows that global state, making it mutable is a bad idea, but still people often pass mutable references to functions and it's still considered okay, and it shouldn't be. It makes code much harder and unpredictable. Don't do it. Then prefer declarative style. I see declarative style as a scale. So whatever gives your intent more, then it's better than the thing that just tell you code what to do, and that's it. And then strive for type safety. I didn't talk about it much, but yeah, if the only thing you need to know about the function you're calling is types of inputs and outputs, you might want to express as much implicit logic into these types as possible. And type safety helps you with this. And it's also a thing that we take care about in functional programming. Then you might look into monads like option and result to use type safe stuff instead of nullable and exceptions. You can try to avoid and isolate side effects, and it will help making your code easier. And then the hard thing, try turning operations into values. It's hard, but it's very useful. The last step is explain the monads to everyone. It's just part of life cycle. You cannot avoid it. Yeah, thank you. And in the end, I want to point you to some resources for learning more about functional programming. First of them is the Scala exercises website, and it's interactive exercises, and it's intended to make you learn about Scala libraries, but because they implement some concepts from functional programming, it also works nice as an interactive guide into functional programming. I can really suggest it. The next thing is the Red Book, Functional Programming in Scala, and it is good. It can be also overwhelming, so please don't start with it. Just get to it once you already started. You have some idea what you're doing, and now you want to deepen and systemize your knowledge. But yeah, starting with it might be overwhelming. And the third thing is book functional modeling, domain modeling made functional. It's more practical. It's also not specifically about functional programming. It's a book about domain-driven design in F sharp, but they implement the application using functional programming. And the author says that domain-driven design works very good together with functional programming, and I can agree. So it's a good practical thing to start. And that's it. Thank you. And let's look at questions.
Add to stage. Hey, thank you so much, Bogdan. That was a real fun session, and I think you had a nice balance of, the technical side and the useful part of functional programming in your session. And I learned a lot. And you know what? I also liked when you kind of closed up and you talked about some of the domain-driven modeling, which was done using F sharp. So I think that's something I can still, possibly get trying a bit because it's
Mhm.
much closer from my background from C sharp and so on. I am having a look at the Hall One chat. Um, I think there is 1 or 2 minutes delay between our presentation at StreamYard and at Pine. So let's give it a minute or so to see if any questions come up. And none as of now. So, Bogdan, let me ask you a question. So, uh, I think for the Scala and the Rust people, there is a very clear move into functional programming. What about, I come from an older generation of programming who've been using C sharp and Java. What about the
Mhm.
Java world? How do the Java programmers move into functional programming? What would be the easiest shift for them?
Well, for Java, I can say use Scala. It's interoperable with Java code, so you can move gradually, and it compiles to JVM, so it's the best way. But also, it's like if you're not coming to functional programming is coming to you because uh, the language designers look at functional programming and still the most useful and easy to implement concepts into their languages. So you have Lambda functional functions in Java, and they are there not just because they decided to want it, they stole it from functional programming, and that's good. So you can see functional programming is winning even in the languages that are opposed to it.
Nope, very much. I mean, Lambda functions is also there in C sharp. So, I mean, I like the way you put it. If you don't come to functional programming is coming to you. I'm going to quote you, Bogdan. I'm going to quote you on that.
Okay.
Perfect. So, Bogdan, you're like, session done. Are you excited to stay in the languages and framework hall? Are you moving to other halls? Do you already have a few sessions bookmarked?
Well, the next one should be Keynote. It
Ah,
sounds
is the
interesting.
keynote on
Yeah.
next?
Well, the main whole. I mean, this.
Okay, perfect. Thank you very much, Bogdan.
Yeah.
Thank you for
Thank you.
kicking off the day on the Languages and Framework Hall.
Yeah. Have a nice
Bye.
conference. See you.
Oh, I need to say thank you.